Good afternoon, everyone, and welcome to WASA Distance Education. This is MBF3C, Foundations for College Mathematics, and my name is Marvin. Welcome to class number 26. We are now into week number 8, and this just 9 weeks in the course. So we have 4 classes this week and 4 classes next week to finish up the course, and that should get us right about there, right on time. So in this particular unit, we've been talking about trigonometry. We looked at sine, cosine, tan, the 3 trig ratios. They can be used to solve triangles, angles, or sides, provided it's a right triangle. So right triangle, you can use the trig ratio, sine, cosine, and tangent. If they're not right triangles, we have 2 options. We have the sine law or the cosine law. Sine law is simply a proportion, so they're fairly easy to do. You simply put in the information, cross, multiply, then divide. Same procedure every time. So if there's a choice, that's where you would want to go. If you don't, sorry, in order to use the sine law, you need to have at least one angle and at least one side and at least a pair of an angle and an opposite side. So if you don't have a pair, like an angle and an opposite side, so the example that we started last week uh, was we had an angle A, 48 degrees. The side C was 138 kilometers, and side A was 96 kilometers. So we had a side, an angle, and a side, but we didn't have an angle and an opposite side. So here we have 48 degrees. We didn't have the opposite side. Here we have the side, but we don't have the opposite angles. So in this particular instance right here, this particular example, we cannot use the sine law. So we have to use the cosine law. We worked through some examples last week of using this cosine law to solve for the measure of one of the sides of the triangle. And we also did some examples where we had to calculate the measure of an angle using the cosine law. All formula based. Once you determine what you have to find, whether it's a side or angle, then you pick out the appropriate formula. That's great when the diagrams are drawn for you. But in some cases, we have to solve word problems where the diagrams aren't given to us. They're not drawn for us. So in those cases, you'll have to uh, do the draw the angles and the sides yourself. So this particular one that we looked at, and we drew the diagram already. So sample problem 13.3, it says, 2 ships are sailing from St. John's. The dory is sailing due east. When you think about due east, it's just straight off horizontally to the right. So that's the way that ship is sailing. And the punt is sailing 48 degrees south of east. So 48 degrees south of that line is the direction that the punt is sailing in. One is probably going to Europe. The other one's probably going to Africa. If you think we're coming from, leaving St. John's and traveling those directions. After an hour, so what we should do to make this problem more realistic, because it says here, after an hour, the dory has traveled 138 kilometers and the punt has traveled 96 kilometers. Ships don't travel that fast in an hour. 138 kilometers an hour is really fast in a boat. So let's alter the problem to make it more realistic. So I'm going to come into here after, let's say, 10 hours. Okay, let's delete that after 10 hours. The dory has traveled 138 kilometers. So that doesn't change anything. because we're looking at how the question says, how far apart are the two ships, okay, after 10 hours? So all we're concerned about is distance and not in with time right now. So we drew the diagram and we labeled the diagram A, B, and C. So here is where, can I cut back in here? So here is the dory. That's where she is. That's where the punt is. But we labeled the vertices, the points where the two sides meet in the triangle is called a vertex. We labeled them A, B, and C. And the reason why I labeled them A, B, and C is if we scroll back up here and we take a look at the formulas for the cosine law, we're dealing with angle A, angle B, angle C, side A, side B, and side C. So it makes it easier just to pick out one of these particular formulas and use it to solve the problem. You could have used any letter you want. You could have picked X, Y, Z, P, Q, R. Doesn't matter as long as you know how to get the right letters in the right spots in the right formula. What I always do, and I've been teaching math for 38 years, and I love this stuff, by the way, and I enjoy doing it, but I still do the same thing that I'm teaching you to do, and that is to follow the steps. Don't skip any steps. Don't try to go too quick. Take your time and follow the same procedure each and every time. So what I'm going to do before I get started is I'm going to label the sides. So this particular angle A, opposite angle A is side A. So we use lowercase letters for that. Opposite side angle B is side B. And opposite side, angle C is side C. The part that we're asked to find is how far apart are the two ships. And you know what? Let's make that. Let's go back in and let's tidy that up as well. And let's say here, after 10 hours. Okay. So something, oh yeah. I'm just going to change my margins a little bit here so it doesn't mess up my formula or my drawings. So the part that I'm asked to determine is how far apart are the two ships after 10 hours. That would be this part right here. So I'm looking for this distance right here. How far apart are the dory and the punt? So I'm looking for side A. Okay, that's what I'm trying to determine, side A. So right here, if you go back up to where we were just a few minutes ago, I've done it for you already. First thing I do is I write down the formula. Here we go. A squared, this is what I'm trying to figure out, is what A is. A squared equals B squared plus C squared minus 2BC cosine of angle A. That's the formula. The next step in the process is to do the substitutions. So B is 96, so 96 squared plus C is right here, 138. So 138 squared minus 2 times B, 96, times C, 138 times the cosine of angle A, which is 48 degrees. Here's my angle A right here, 48 degrees. So I did the formula, did the substitution. So now next part is to simplify. And the simplification part is simply all we're going to do right now is just do the multiplication. 96 squared means 96 times 96, which is 9,216. Plus 138 squared is 19,044. Minus 2 times 96 times 138. And again, use your calculator. And I've done this several times, so I've checked it already a couple of times. But you should be checking these numbers as you're going through, making sure that you're getting the same numbers that you see on screen. Not getting the same numbers, you're probably making a mistake how you enter the values into a calculator. So go back and double check. If you need some help, give me a shout. So now I simplified that part. Now I'm going to simplify even more, a couple more times. So I've simply added these two numbers, 9,216 plus 19,044. Those two numbers add up to 28,260 minus 26,496 times cosine of 48, sorry. So now I'm going to do all of this in one shot. So we do 28,000 minus 26,496 times cosine of 48. You'll get this number. Don't round the number off. Okay, so don't round. When we're doing mathematics, we only round in the very last step. So for now, we're not going to round that number off. So if a squared is equal to this, the inverse or the opposite of squaring a number is taking the square root, and that the square root of a squared is a, not r. So that should be a equals the square root of that. So a is equal to 102.6. So this value here is going to be 206. What let's, oh, sorry, 102, so 102.6, and we're talking about kilometers. So there's the units, kilometers. So the two ships, now this little symbol here, I'm starting to use it now. That little symbol, triangle, means therefore. Okay, so we've simplified. So this involves a few more steps than using the sign language. It's not difficult. Once you get used to doing this, it's not a difficult process. Okay, so practice makes perfect. So if you work through several examples and you're checking my work as I'm doing it, and you're getting the same numbers that I'm getting, then you know you're doing it right, and then you should be go. So the last step is to write a formula. Sorry, write a statement at the end and answer the question. So therefore, the two ships are 102.6 kilometers apart after, and we said 10 hours. Period. So that is how you would solve a word problem. First, draw an accurate diagram. Formula, substitution, simplify till you get to the answer. Follow these steps, and then write a statement at the end answering the question. Okay. So leave that for now. So that's it for that particular lesson. Lesson number 14. So now you have enough information that actually, before we move on, let's look at not the key questions. Let's come back up to support questions right here. I want to get you started on one of these. So these occur quite often. So number 3, it says in triangle PQR, find the value of R if P equals 13 centimeters, Q equals 8 centimeters, and R equals 63 degrees. So here, there's no diagram. So you have to draw a diagram. Now, It doesn't have to be to scale and doesn't have to be 100% accurate, but try to be as accurate as you can. So remember that opposite angle R is going to be side R. So side P and side Q are going to make up angle R. So if I draw a diagram, let's draw a, I'll do it in red because this will be part of the solution. So P is 13 centimeters and Q is 8 centimeters. So P is longer, Q is shorter, and angle R is 63 degrees. So if I just go like this, now P is going to be the longer side. So we call this P. Q is shorter, and the angle R is 63 degrees. So 63 degrees would probably be something like that. This would be angle R. That would be side Q. This angle right here is R, which is going to be 63 degrees. This angle right here, 63 degrees. This should be a straight line, but it's hard to do when you're using a mouse. And then I'm going to finish off the triangle. So this is PQ. This would be side R. Opposite side Q would be angle Q, and opposite side P would be angle P. So there's PQR, PQR. There's my triangle. P, this part right, I'm going to change the color for now. P is 16. No, sorry. P is 13. Come back into here. P is 13 centimeters. Q is this part right here is 8 centimeters. And again, I apologize for the drawing. This should be straight lines, best as I could do for now. So I've entered all of the information. Find the value of R. So this is the part you have to find. Now, we have a side, an angle, and a side. So when we have two sides with the included angle, we have to use the cosine law. Okay, I'm just going to cosine law. Okay. Because we don't have, so we have the angle, but we don't have the opposite side. Half the side, but we don't have the opposite angle. Half the side, but not the opposite angle. So we can't use the sine law. So we have to use cosine law. So I'm going to leave it there with you. Um, now that you know what you have to do, you got to use the sine, a cosine law. So now it's simply a matter of writing down the correct formula. So I can do that for you for this one. Come back up here in red. So we're solving for R. So R squared is going to be, think Pythagoras, P squared plus Q squared minus 2 times P times Q, P Q times the cosine of this angle right here, cosine of angle R. Okay, so R squared equals P squared plus Q squared, just like Pythagoras, minus 2, these two right here, PQ, times the cosine of the angle corresponding to the side we're trying to determine. So now it's simply a matter of doing the substitutions, and you should be off and running at that point. Okay, so that finishes off lesson number 13. You now have enough. You can solve these. We did an example like these. Here we have a couple of word problems, 2, 3, 4 word problems. where you're going to have to draw diagrams first to make sure uh, if you tried solving the problem without drawing a diagram, it's going to be really, really tough. So I would say it's not impossible, but it's going to be very difficult to do without drawing a diagram. So get down to business, draw the diagrams, and you should be fine. And if you draw the diagrams and you're off a little bit and you enter all of the numbers and you do all the calculations right, but it's not, the diagram wasn't quite right, so your answer's not quite right, then you're going to get a lot of marks anyway, just for doing if you solve the formula and arrive at an answer that would have been right if you hadn't drawn incorrectly, you're going to get a lot of marks. So keep that in mind. So 14, lesson number 14 is titled Trigonometry and Problem Solving. So essentially what we're just doing. So we're going to be looking at diagrams now. Here, there's a couple of ones done for you. SOHCAHTOA, I'm going to just put a space in between here because it should be spaced out. SOHCAHTOA, if you have right angles. So right here, that's a right angle. There's a right angle. So we can use sine, cosine, or tan. And if you have a choice, I mean, sine, cosine, or tan are pretty easy to do when you think about it. Once we get into non-right triangles, if you have three sides, you've got no choice but use cosine. Okay, no choice. Sine law, you need at least a pair of an angle and an opposite side. You need at least one angle to use the sine law. Don't have that, so you got to use cosine law. And then there's some support questions, diagram there for you, a diagram here, but then there's a couple where there are no diagrams. So what I want to do now is do a quick review, then I'm going to work through some word problems with you so that you'll be ready for the key questions when you get to them. So trigonometry, three parts. The ratios are sine, cosine, tangent, and they work when you have a right triangle. Again, one of the angles has to be 90 degrees. If you have a 90-degree angle, you can use SOHCAHTOA. Sine is opposite over hypotenuse. CH is cosine is adjacent over hypotenuse. And TOA is tan is opposite over adjacent. These are ratios because it doesn't matter how big the triangles are. I mean, I can make that triangle double the size. Angle A and angle B and angle C will not change. The measure of those angles will remain the same. So the tangent and cosine and sine are all ratios. So you're going to get the same value as long as the triangles are proportional. They're enlarged or smaller. Sine law, sine law. Sine of A over A equals sine of B over B equals sine of C over C. That's the way I tend to use the formula. You can use the other one, A over sine of A equals B over sine of B equals C over sine of C. But most people stick to the first one. Doesn't matter. The important part is labeling the triangle. Opposite angle A, which is an uppercase letter, we use a lowercase letter A, side A. Opposite B, angle B is side B. Opposite angle C is side C. Again, vertices or the angles are uppercase letters, and the sides are represented by lowercase letters. Same thing for the cosine law. Opposite angle A is side A, opposite angle B is side B, opposite angle C is side C. Three formulas is essentially the same formula. It depends on which side we're trying to determine. C squared equals A squared plus B squared minus 2AB cosine C. So again, the formula is the first part will be just like Pythagoras, C squared equals A squared plus B squared. Then we're going to subtract 2 times the two sides that are over here on the same side of the equation, AB, minus 2AB times the cosine of angle C, which is the side that we're trying to determine. So starts with a C, ends with a C. Starts with a B, ends with a B. Starts with an A, ends with an A. Starts with a P, ends with a P. Starts with a J, ends with a J. Okay, so the angle and the opposite side are paired up, beginning and the end, and then in between is the other two sides squared minus 2 times the other two sides. When we're trying to determine the measure of an angle, if we know all three sides and none of the angles, then we can use C cosine of C equals A squared plus B squared minus C squared all over 2AB. Cosine B equals A squared plus C squared minus 2B, or sorry, minus B squared over 2AC. And then cosine of A equals B squared plus C squared minus A squared all over 2BC. So the cosine of the angle and the side we're working with only occur once. There's cosine C, there's a side C, and then there's side A squared, side B squared over 2AB. So these two are paired with the 2. So if A squared plus B squared, 2AB, A squared plus C squared, 2AC, B squared plus C squared, 2BC. So there are ways of, so I've dealt with these formulas a lot over the years, so I just automatically remember them. If you don't use them a lot, and we're going to do lots of examples, and you might remember them while we're doing the key questions and we're working through problems in the course. But 2, 3, 4 years from now, if you don't use it again, you're probably not going to remember the formulas. But as long as you remember how to use them, you can actually just go online and look them up. So let's look at a couple of problems. So problem 14.1, Sally stood 75 meters from the base of the CN Tower and looked up to the top. She measured the angle of elevation to the top to be 82 degrees. If Sally's eyes from where she stood took the measurement are about 1.5 meters above the ground, how tall is the CN Tower? So when we measure an angle, we usually, using a tripod or some sort, and that's going to be a certain distance from the ground, so we have to account for that. So now let's draw a diagram. So if I look at the diagram, I'll use black for that. Okay. So we're looking at the CN Tower. So here we go. I'm just going to draw the CN Tower, and it's got a ball on it right here. I'm not very good at drawing, by the way. So that's the CN Tower, believe it or not. 82 degrees, so she's standing from the base of the tower right here, and she's looking up at the top. Oops, maybe I'll come down. Might be easier where I come down. So from here, she's looking. Now she is standing. Let's say she's using a tripod to measure upward. So this angle, so this is where her eyes are. So if I were to draw a stick man, there's her eyes, and she's standing on the ground. So Sally stood 75 meters. So from here to there is 75 meters. So she's standing on the ground, 75 meters from the base of the tower. She looks up at the top, and this angle is 82 degrees. Okay, so this angle right here, 82 degrees. And she's 1.5 meters tall. So from her eyes to the ground is 1 point. So if this is 1.5 meters, this distance right here is also 1.5 meters. Okay. So notice angle. Now, the CN tower is perpendicular to the ground, and it has to be because when you build a tall structure, and if it's not vertical and it's tilted, eventually gravity will pull it down, will fall over. So it's got to be perpendicular. So that means we have a right angle. So if we have a right angle, we can use SOHCAHTOA. So S-O-H, Ka, C-A-H, and TOA, T-O-A. We can use one of those three. So we have an angle. So let's label the parts. So now because we're dealing with a right angle, we have to label the parts. So let's make this red. So we're going to be dealing with this triangle right here. So we're going to go across here. We're going to go, so we're dealing with that triangle. So we have the angle, 82 degrees. This is 75 meters as well. So we have an angle. This is the opposite side. So what we're going to figure out first is this distance right here. How tall is it from her eyes to the top of the building? Let's call this height of the building. So we'll call it H for now. So we have here, we have the angle. We're asked to find the opposite side. And we're given the, this right here is 75 meters. This would be the adjacent side. So opposite and adjacent is tan. So we're going to be dealing with tangent. So what I've done, just to speed things up a little bit, I've actually done this part for you for now. I'm just going to pull this up right here and see if I can't. Let's do it right here. Let's come back over here. So the first part I did right here was I entered the formula. So I'm going to make that opposite over adjacent. So there's the opposite side, there's the adjacent side. I've entered the formula. So there's the first step. The second step is to do the substitutions. So we have tan of the angle is 82 degrees equals, now here I used X, so I'm going to change this here. And again, the letter you choose is entirely up to you, but here we used X, so I'll call it X here as well. So X over 75. So what's probably the best thing to do now is to make, I always say, make this a proportion, make it over 1. So tan of 82 over 1 equals X times 75. Cross multiply, 1 times X is X. And then tan of 82 times 75, 75 times the tan of 82. Now just plug those numbers into your calculator. And again, do the math with me. 75 times tan 82. Press enter. You'll get 533.6527292. I only go 2 numbers after here because we're talking about meters. So this would be 533 meters, or 533.65 meters, which is 533 meters and 65 centimeters. That's why I use the 2 decimal places. And then I'm going to come down here, and then I'm going to back this up, and then I'm going to write a statement. And then what I've been doing lately as well, and it's just a good habit to get into. So when I come here, actually, I can just go up here. What I want to do is grab that. Actually, no, I won't do that. Oh, no, I'll do it a different way. There's always more than one way to solve a problem. And I'm going to do it this way. So I'm going to go insert, oops, insert. I'm going to get rid of that and the equation, and then it's, where is it here now? The very end, right there. Put it in. Therefore, the CN tower is 533.65 meters tall. So diagram, determine what I had to do to solve the problem, do the substitutions, and then work it out. So there is a problem involving, again, because it's a right angle triangle, we can use SOHCAHTOA. Nice and simple and fairly quick to get to the answer. So let's try another example. This one, sample problem 14.2, an airplane is flying at an altitude of 1,200 feet. The pilot spots an airport at an angle of depression of 15 degrees. What is the distance he must travel in order to be directly above the airport? No, he is not landing at this airport. So we're looking at a problem. So let's draw a diagram. And again, this is going to be the most important part, is drawing a diagram and making sure that it's fairly accurate. Okay, so let's get back over here. So he's flying an airplane and is at an altitude of, so altitude means how far off the ground is he. So let's draw a diagram. I'll use black again. So again, I'm not very good at drawing, so let's go, an airplane's got a tail on it, like that. That's not very good. Let's try that again. So an airplane, and again, there's an airplane. I'm going to put a point right there. That's where the plane is right now. The plane, right here, at an altitude of 1,200 feet. And again, because we're Canada, let's go back here again. Let's go turn the draw feature off for now. And we're going to change that to 1,200 meters. Okay, so 1,200 meters above the ground. So this, and again, this is vertical, so straight up. $1,200. And that's meters. Okay. Now, here, over here, there's an airport. Right here. There's the airport. So the angle of depression, I'm just going to draw a dotted line. This dotted line is parallel to the ground. And from here, should be a straight line. Sorry, it was not. So the angle of depression is right here. Okay, so angle. So the angle of depression is the angle between from the horizon down to the point you're looking at. PRE. Again, it's difficult to write with a mouse, so excuse the writing. So the angle of depression is right here. This angle right here, if you're looking from the airport up at the plane, this angle right here is the angle of elevation. This angle, sorry, that angle and this angle are equal. They're both the same. If you're 1,200 meters above the ground here, when you get over here, the distance, you're still going to be 1,200 meters. Okay? So we know that 1,200 meters above the ground, we know that this is a right angle. Okay? And the angle of depression is 15 degrees. So that means that this one right here, this angle right here is 15 degrees. And you're asked to find the distance you traveled from here, and you're not landing, you just continue to travel. So you're looking for this distance right here as well. So this distance and this distance is the same. So we have an angle, we have a right angle, so we can use SOHCAHTOA again. So S-O-H, Ka, SOHCAHTOA. So we can use one of these three. So we have to label, change this to red now, we have to label the triangle based on the parts that we know. So there's the angle. Opposite the angle over here is 1,200. That's the opposite side. This is the adjacent side, which is the part we're asked to find. So opposite and adjacent, again, is going to be tangent. Because in order to use cosine or sine, you need to know the hypotenuse, which will be this one right here. So now I know what I have to do. I got to use tangent. So now the next part is to write the formula down, which I've already done for you. I'm just going to pull it back up here now so we can work on it and make that formula. First step. Okay, so let's run the formula. Oops. And okay, get out of here, get out of there so I can draw. Formula is down, opposite over adjacent. Now let's do the substitution. The angle is 15 degrees, so tan of 15 equals. Opposite side is 1,200 over this side right here is going to be x. We can use any letter. It's up to you. In this case, we use x. So now again, let's make this tangent as any number over divided by 1 is itself. So tan of 15 divided by 1 is tan of 15. But I just do it this way to make it easier. You know, and once you get used to it, you don't need to put the 1 there. But cross multiply, 1 times 1,200 is 1,200. And then x times tan of 15 is x times tan of 15. We don't write a multiplication sign. Now we're going to divide each side of the equation by the tan of 15. And we do that because tan of 15 divided by tan of 15 is 1. 1 times x is x, which is what we're looking for. And then it's 1,200 divided by tan of 15. So grab your calculator and you're going to type in 1,200 divided by tan of 15. Press equal and you get 4478.460969. Round it to 2 decimal places, so it's going to be 4,478.46 meters. So over 4,000 meters, so by 4 kilometers, 4.5 kilometers almost. So again, diagram, it's important. Determine which formula you have to use, or which ratio, or which law. Write the formula down, do the substitutions, and now I'm going to come back up here and I'm going to, from now on, you're going to see me use this symbol right here, therefore, in my statements. Whenever I state an answer, I'm going to put that therefore statement there or therefore symbol there. And again, that's just something that I was taught when I was in high school and university, and I'm just going to continue. So therefore, the pilot must fly 4,476 78.46 meters to be directly above the airport. Again, diagrams. Drawing an accurate diagram is important. Try once more. So now we have practice problem 14.3. So those two both involve tan. Rachel is fixing the soffit on her house. She has a 20-foot ladder that she places 4 feet from the foundation of the house. What is the angle of elevation between the ground and the ladder? So what we have to do again is to draw a diagram. Okay. So so we're talking about a house. So let's do, and again, I apologize because my drawing skills are not that great when we're dealing with trying to draw with a mouse freehand. So I'm going to just draw tall, skinny house, let's say. So there's the house, there's the ground. And of course, we're dealing with 90-degree angles here because these buildings are perpendicular to the ground. They have to be, like I said, if not, they would fall over. We don't want that to happen. So I'm just trying to get what I'm going to zoom back over here a little bit so I can. Okay, there we go. Rachel is fixing the soffit on her house. She places a 20-foot ladder 4 feet. So she's going to be 4 feet from the base of the house. So this is going to be 4. I'll leave it as feet for now. And then she places the ladder somewhere up here. It doesn't have to be at the very top, but she's going up here. There's the ladder. And the ladder is 20 feet long. And the ladder is 4 feet from the house. So that is easily to calculate. You can take a tape measure, you can measure. So what we're asked to find is what is the angle of elevation, which would be this part right in here. That angle is what we're looking for. So the solution is going to involve labeling the parts of the triangle. So if this is the angle, the part we're given here is the adjacent side. And this part right here, which is opposite the right angle, is the hypotenuse. And this would be the opposite side, but we don't need the opposite side because we don't need it for our calculations. So we have to use, again, SOHCAHTOA. So, ka and toa. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Toa is tan is opposite over adjacent. So we're dealing with the hypotenuse and we're dealing with the adjacent. Adjacent and hypotenuse would be cosine. So in this particular case here, we're going to be using cosine, and we're using one of the 3 ratios because we have a right angle. So we can use cosine. So we're pretty much run out of time for today. So we're going to stop right there. We'll pick up from here tomorrow. Finish the problem off. We're going to look at a couple of more. Then we're going to get into lesson number 15. And we could probably do lesson number 15 because it's a relatively short lesson. We could probably do that tomorrow as well. And then we'll be finished with this particular unit. Thank you for participating in today's class, and I look forward to talking to you again tomorrow. Bye for now.